Okay, so you were finding area today in class, and today we're going to practice finding the volume of certain figures. Now, what happens with volume is that we just don't look at a figure and find the volume. We actually rotate a part of the figure around the x-axis or around the y-axis or around some other line. And when we rotate it, then we can find the volume of that figure. So, let's say that we have y equals 3x, y equals 0, and x equals 2. And we're going to rotate around the x-axis. Alright, so first of all, we're going to draw what this says. So y equals 3x, I'm going up 3 and over 1. X equals 2. So here's y equals 3x. Here's x equals 2. Y equals 0. That line really should go through 0, 0. I'll redraw it for you. There we go. Y equals 0 is that line. So we're talking about this figure right here. Okay? And what we're going to do is we're going to take that figure and we're going to rotate it around the x-axis. So, to demonstrate that a second, I'm going to go to the computer and I want to show you sort of what it looks like. You don't have to know what every single thing looks like, but it does help you a little bit to understand it if you can see it. So, this part right here is where we've drawn the figure. Okay? This over here on the right, that's where they've drawn it, and they've drawn it three-dimensionally, so I'm going to show you the process of getting what it looks like. It's not rotating it well. Let me see if I can do that a different way. Okay, here we go. So there's the figure, and then we're rotating it. Now I'm going to turn it around so you can sort of look like it. It basically sort of looks like a cone. And see, there's where if I continue it, you can see the rest of it. And so it's a cone and it's filled in. That's sort of what the figure looks like. Okay, so back to what we were talking about. We're going to rotate this thing around the x-axis. And see, if I draw it over here, you can sort of think about it rotating the way I just showed you. And if it would continue, basically it's a cone. And so we're trying to find the volume of the cone. Now, you could probably figure out the volume of the cone without having to do calculus. But some of these figures are not going to be normal figures like a cone. So there's a process that we're going to use to find this volume. Alright, what we're going to do is we're going to take a slice of the cone. So think about slicing the cone and looking at it. You would get this little red circle here. And what I'm going to do is I'm going to find the area of that circle. So first, let's find the area of that circle. The area of the circle would be pi r squared. Alright, so the radius here is the distance from the curve to the x-axis, which is what you're rotating around. So the distance of the radius is 3x. So we're going to put a 3x in there. Now that's the area of that circle. Well, what if I wanted to find the area of that circle? Would it be any different? Well, not really, because still this equation is 3x, and that distance right there would be whatever I find the x value, it's however the y value is. That's the height of that circle. So it would still be pi r squared, or pi times 3x squared. Now what I want to do is I want to add all of those circles together. I want to go from here to here, and I want to add all those circles together. If I add them all together, then that would give me the area of each one of them, which would basically give me the volume of that 3D figure. Okay? So to add them together, that's where we do an integral, because an integral is we think of it as area under the curve, but it's also the summation. It's all these things added together from 0 to 2. And so this particular equation right here, in terms of x, so we put the dx, is the equation for the volume of that figure rotated around the x-axis. And I'm just going to put that in the calculator. I'm going to go to Math 9, 0, 2, and 3x squared. You could put 9x squared if you wanted to. Put it in terms of x. Now I didn't put the pi in there, and I end up with 24 pi. If you put the pi in there, you would go ahead and get whatever that decimal was. Okay, so here's another one. This is y equals x squared, y equals 4, and the y-axis. And so if you graph that, here's the figure that you get. And again, I want to rotate this one around the x-axis. So as far as the picture goes, it's just basically this parabola. We're going to rotate it. So I'm going to go to the computer and show you sort of what the computer shows you. So over here on the right would be the part that's rotated. And hopefully you can see how it's starting to form the figure. We can sort of look at it again. And so that part right there is actually not the whole entire figure that was shaded. That part right there is the part underneath the parabola. That's actually what we're going to have to get rid of when we talk about this particular graph. Okay, here it is, and maybe it'll look a little bit better. But we start rotating it. And see, it looks, I'll turn it around for you. See, the outside of it kind of looks like a cylinder, but the inside of it is this little cone thing that's cut out of it. That thing I showed you first, that's the part that will be cut out of it. If I was just rotating this part right here, that's this inside part right here. But I'm rotating that outside part, and that's what this is outside of here. If you're confused by the graphs that I was showing you, that's okay. You don't have to do that every time. I just thought for some of you that you would like to see like that 3D animation there. So here's x squared, here's y equals 4, here's the y-axis. So this is the part that we're looking at. You'll use your calculator or figure out what you need to know, but this is basically at 2. This is at 4. We're rotating around the x-axis, okay? And so when I do that, I sort of, if you want to draw it, kind of draw the same thing kind of underneath the x-axis and just sort of think about it. Basically what's happening is that the outside of it is a cylinder and the inside of it is a cone. So what we're going to do is we're going to have to take the whole cylinder part, and then we're going to take the cone part, and then we're going to subtract it. Okay? We're still going to use the process we talked about, where we do pi, and I'm going to call it a big R for now, because basically we're going to take the whole cylinder, and then I'm going to call the little one little r squared. So starting with the big radius, it's like from the outside of the function to where you're rotating. So that's 4 minus 0. We can just call that 4. And then the inside, you start from where you're rotating on the inside and go to the x-axis. And see, this particular graph where that point is on is x squared. This is 0. So this is x squared minus 0 squared. So that's sort of the area of the cylinder minus the area of the cone, because what's going on, it's not a great picture, but there's this cylinder, and there's that cone, and I'm taking the cone out of it. And I'm just trying to find whatever this figure is, where it's a cylinder out of the cone. Okay? Now, to finish the problem, it would be an integral, because the integral says add it up from the left to the right. The left is 0, the right is 2, so this would be the entire equation. Alright, we're going to look at another one, and I won't draw this one on the computer. But that'll give us a good idea of some other ones. So we have y equals x squared plus 2, another parabola, but it's up 2. Y equals 3. And the y-axis. If it doesn't tell us the y-axis, we would use that whole little, we would use this left part and the right part. But since it tells us the y-axis, we're only using this part. And we're going to rotate this around the x-axis. Okay? So this particular figure is a really strange one. If I drew that same thing down below, I get something like that. So it's sort of this big cylinder thing with part of a cone right here, that purple part of a cone. I'll do it in green so that doesn't confuse us, but that is what's cut out of it. So it's these little, I don't know what that is, but anyway. That's what we're talking about, and that's what the purple part is the part we're trying to find the volume of. So what we do, again, is we're going to take the volume, or the area of a circle, so we're going to find like the area of this circle right here, and I'm going to change that color so maybe you can see it better. The area of this circle, and the area of this circle, and we're going to subtract those two things. Okay, the area of the big circle. When I do this, I always think about, okay, it's on that graph and it goes to there. So you start where the graph is and go to where you're rotating. That would be always 3, since the line is 3 and always going across. So that would be pi times 3 squared. Then we're going to subtract something else. And that's what this other little part is. Take what you're rotating and what you're rotating around. This first one here is on x squared plus 2, so this is x squared plus 2 squared. An integral adds all of that up, and then we're going to go from 0 to wherever this is located. You might have to use the calculator, or you could plug 3 in for y and solve. I believe that you'll get x equals 1, so that would be the integral that you would set up in the calculator. When I do it, I'm just going to do it without the pi's, but you can do it with the pi's. It doesn't matter. I'll show you what I put in the calculator. So this is what it looks like when you plug it into the calculator the way that I did it. And so your answer, if you want to write it this way, would be 3.466 or 67 pi. Or if you want to change that to a fraction, you can do that. You would get 52 over 15 pi. Or if you want to multiply by pi and say that the answer is 10.890 or 1, any of these answers would be correct. I think sometimes it's easier not to put the pi in the calculator. I just think it looks easier, but you can do it however you want. Okay, we're going to try another one. I think this would be our fourth example. And we're going to let y equal x to the 1/3 and y equals x over 4. And I just graphed it in the calculator. The blue is x to the 1/3 and the green is x over 4. I'm going to go ahead and find the intersection points. I know that that is at 0, 0. Let's go ahead and find that one. You can do second calc intersect. Or you can set them equal to each other, figure out what it is. And I got the point 8 and then 2. Alright, so what we're going to do is we're going to rotate this figure, this purple part, around the x-axis. I'm just going to kind of draw it to give you an idea of whatever this is. So it's kind of like maybe a bowl, kind of a half of a cylinder, half of a sphere, and then this little cone is cut out of it. The red part is the cone, and that's the part that's cut out of it. Alright, so what we're going to do, I'm going to take off the red part just so that it's easier for us to see. What we're going to do is same thing, start with the very outside function, go to where you're rotating. We're going to find the area of that circle. So that would be pi times the outside function, the one that's kind of connected to that red, is x to the 1/3. So that would be pi times x to the 1/3 squared. And then we're going to subtract the other little circle, which it starts on the inside with the green. So that's the circle there, that radius. And you know what? I didn't draw that well because the circle should really come all the way down because the radius is just to the x-axis. But anyway, so the radius there, it goes from that green to the middle. That's the radius of the full circle. So that would be pi times x over 4 squared. And then we're going to do the integral. And then we look at where we start and where we end. So that would be from 0 to 8. I'm going to go ahead and put that in the calculator, and I'm going to see if I can find the answer. Alright, that gives me 8.533 pi. And then if you want to multiply by pi, up to you, but you get 26.808. So probably one of your biggest questions is, well, how do I know if I do like on the first one and I just have something pi times something squared, or if I have pi times something squared minus pi times something squared? What matters when you're looking at that is if you have something cut out of it. So let's say I have this figure, and I have maybe the same figure, but it's up here. If I'm rotating around the x-axis, the first one has no hole, so it would be the integral of something to something with a pi. You can put the pi on the inside or outside, times something squared. The second one, if you'll notice, see the first one's more like a cone, I guess, or it depends on if that's a curve or not. The second one, it would be something minus something, and those two blue lines represent the radius, and that's because there's that inside part when you rotate around that you would have to cut out of that. So it would be the integral of pi of something squared minus pi of something squared. So what I'm going to do is I'm going to, these are going to be your try problems. And what I'm going to do is I'm going to go ahead and tell you the equations of all that stuff and see if you can put it in and get the answer. So the red over here, we're going to let that be y equals 5x. We're going to let this red line going up and down, we're going to let that be at x equals 3. And then the x-axis is also part of your boundary. You won't need that much. So that's those 3 parts. Okay, this one over here on the right, we're going to let that line be y equals 5x plus 4. That's what that will be right there. And then this part right here, we'll let that be x equals 4. And then this part right here, we'll let that be y equals 2.